Hey guys, today we're going to talk about expected value, just kind of like a quick lesson on what expected value is and how to calculate it. So just as a warm-up, if you toss a coin 10 times, what do you think the most number of heads that you can get is? You probably said to yourself 10 because you can get heads on every single roll. What's the least number of heads you can get? You can get 0 heads. You can get tails every time. But because the probability is 50%, maybe I think that I'm going to get 5 heads when I do toss a coin 10 times. If you toss a coin 100 times, the most number of heads you can get is 100. The least number is 0. But again, I expect to get about 50 because that probability is 1/2. If you roll a die 10 times, add up all the numbers from each roll. The highest you can get, so if you get a 6 10 times, the highest you can get is a 60. The lowest total you can get is if you get a 1 every time, which is going to be 10. However, because I'm averaging those values together and what I think if I get a low value and then a high value, then a low value and a high value, maybe I'll get somewhere around a 35. So if you roll it and get a 6, then a 1, then a 5, then a 2, and if you add them all together, maybe that sum will be 35. So that's kind of an idea of what expected value is. It's being able to think about what could happen in all instances. So expected value is a weighted average. Now look at this formula, it looks really scary. But essentially all you're doing is you're taking the term and multiplying it by the probability. So you're taking the number of times that you do something, multiplying it by the probability. It's called a weighted average. It'd be calculating by multiplying the value of the possible outcomes by the probability of that outcome. So you can be like, let's just say you have a 10% chance to get, a 5, and you have a 90% chance to get a 10. So I'm taking the probability as a decimal, multiplying it by the potential outcome, and then that is my expected value when I add them together. If I were to lose money, I would have to subtract. So losing money subtracts from your expected value. So if you were to get, let's say, a 10% chance that you get $5, you have a 80% chance that you get $10. But in an instance, you have a 10% chance that you lose $10. So if I'm losing money, that value has to be negative, which ends up making this right here a negative that I'm multiplying by. So if you lose something in a situation, that weighted average is decreased, whereas if you're gaining, the weighted average is increased. So let's look at an example. Suppose you ask your dad for some money. Instead of giving you money, he proposes the following. He will flip a coin. If the result is heads, he'll give you $20, but if the result is tails, he'll give you nothing. So what is the probability of getting a heads when you flip a coin? And we know that that probability is 50%, so 0.5. So I have a 50% chance of getting $20, and I'm adding that to what my next outcome is. But I also have a 50% chance of getting 0. When you put this into your calculator, you'll find that your expected value, if you were to repeat the process many, many times, is going to be, on average, you expect to get about $10. So even though you're kind of like gambling that you could get 0, you could get 20, if the process were repeated, you'd expect to be $10 ahead. You say, hey, that's too much effort, and you ask your mom for some money instead. She overheard your conversation with dad, and she wants to play the game too. She will roll a die, and she'll give you $3 for each of the pip, that's like the little circles, that show up. So if you get, so there's a 1/6 probability that you'll get each individual pip thing. So I'm going to just leave it as a 6 instead of rounding that. So there's a 1/6 chance that I'll just get $3, because 3 times 1 is $3. There's a 1/6 chance that I'll get 3 times 2, which is $6. There's a 1/6 chance that I'll get 3 times 3, 9. 1/6 chance of 3 times 4, which is 12. A 1/6 chance of 3 times 5. And a 1/6 chance of 6 times 3, which is 18. So this is all the possibilities. When you add those values up, So I'm just gonna plug this into my calculator real quick. Just give me a second. When you add all those values up, you get an expected value of $10.50. So which offer should you take? Well, which one gives you more money? And that's going to be mom. So you're multiplying the probability and then what could happen. Let's say instead of, let me read this next one. Let's say instead of the flipping the coin situation. So if you flip a coin and get a heads, you'll get $10. But if you flip a coin and you get tails, you'll lose $3. So the way that you set up this expected value is you take your probability times what you could earn, multiply it by 10, and then I'm going to add the probability of what I could lose, which I could lose $3. So I made that value negative. So when I plug this in, my expected value, my weighted average of everything, is going to be $3.5. So I expect to get $3.5 if I were to play this process many times. So just kind of basic expected value. Give that half sheet of homework a try and let me know if you have any questions.